One of the major hallmarks of aging is the decline of regenerative capacity of our tissues. There are stem cells residing in our muscles, for example, that can leap into service at the first sign of injury to repair any damage. Is the waning of tissue renewing ability due to some intrinsic property of aging stem cells, or a consequence of being trapped in an aging body? To find out, researchers grafted the muscles of old rats into young rats and vice versa. Inside the young rat, even the weak, atrophied muscles of extremely old rats at the end of their lives regained their strength, volume, and ability to regenerate. They became young again, so the capacity was still there all along. And young muscles in old rats lost renewal capacity. So it appeared to be something about the surrounding milieu rather than inherent defects with age. To see if the critical elements were circulating in the bloodstream, old muscle stem cells were cultured in the blood of young animals. This alone had a rejuvenating effect, suggesting that there may be some sort of vitalizing factors in youth that we lose as we age, or inversely some repair-repressing component that builds up. Either way, this may be good news, because if we can find out what those factors are, we may be able to slow aging or even reverse it. Could more than just muscle be restored? What about the brain and all the other organs? To see the extent in which circulating factors might play in affecting aging, researchers turned to a macabre procedure called parabiózou, from the Greek para, meaning next to, and bios, for life. It was an attempt to recreate the phenomena of conjoined twins in a lab by sewing animals together to study the effects of transmissible factors. Conjoined twins are often referred to as Siamese twins, due to the notoriety of a 19th century pair of Siamese American brothers joined at the chest. The Blodgett sisters are the only conjoined twins on record ever having given birth. Josefa and Rosa Blodgett were quite literally joined at the hip. When Rosa got pregnant, both of their breasts developed and started lactating, supporting the theory we now know to be true today, that lactation is regulated by hormones that circulate in the blood. So what about aging factors circulating in the blood? Surgically, researchers can connect the skin, circulation, muscle walls, body cavities, and shoulder blade joints of two animals. Early attempts to graft different species failed, for example, mammals to birds or a cat to a rat. But in 1862, a pioneering French scientist was able to successfully pair together two young rats. Now, the first heterochronic union, hetero meaning different, chronos meaning time, the first heterochronic union was created in 1955 to answer the question, what would happen if you bathed the tissues of an old animal in the blood of a young one? The title of the paper was Experimental Prolongation of the Lifespan. Old rats hooked up to young rats lived about 20% longer than old rats hooked up to one another. Subsequent experiments showed old mice coupled with young became healthier, stronger, and smarter. Aged tissues in a number of organs was rejuvenated, including the brain, heart, pancreas, skeleton, and muscles. That doesn't necessarily mean that aging was slowed, though. Rather than some sort of restorative blood-borne factor, maybe the older animals were just taking advantage of the reserve organ capacity in the younger animals, like having an extra set of youthful kidneys. To see whether there's some aging or anti-aging transmissible element, rather than sharing organs in an entire circulatory system, what about just getting a transfusion of young blood? After all, as an American Aging Association Journal review concluded, the use of parabiózou in humans is currently not performed due to these surgical complications and resulting undesirable lifestyle. You think? But getting a transfusion of young blood would be easy. Does it work? We'll find out next.